Alright, so let's look at the big daddy of all volumetric techniques, titrations. So, titration. A titration is when we neutralize an analyte to its equivalence point, say what that is in a second, to determine its concentration or how many moles of the analyte is actually there. And we do it using this super rad equipment over here. This is a burette, by the way, and this is a conical flask. And this is where the actual titration will occur. So, the volumes of all substances need to be known super accurately, or as accurately as possible. And you need to mention how accurately you know it as well. So we use a burette and a volumetric flask. We do not use a measuring cylinder. We do not use a beaker to measure stuff. I mean, you don't do that anyway. But in this case, we're using volumetric flasks, pipettes, or pipettes, whatever you want. Volumetric flasks, pipettes, and burettes. It's all cool. Now, what it does is it compares the analyte, or it titrates the analyte. That's what it means. Titrate means to compare an acid and a base to the point where they react. Or we'll stick with an acid and a base. Compare an acid and a base to the point where they neutralize each other out. So, with a titration, we compare a primary standard. These are made by the chemist. Or a secondary standard. Now, these are not made by the chemist, but you work out how accurate they are. You work out their precise concentration using a primary standard. We'll get to this in a minute. So we compare our analytes to primary standards or secondary standards, and this allows so that we know the concentration accurately. And this is how we work it out. We use an indicator to show when it has reached its equivalence point. Now, the equivalence point is when it is all neutralized out. It's turned all of the acid into the salt. So it looks like this. Okay, so here we're neutralizing 0.1 molar hydrochloric acid to 0.1 mole sodium hydroxide, and we can see that you add 25 to 50, and at this point here, we would start to get a very rapid change. Okay, and that's where it would change color. In this case, you would be using phenolphthalein. So this is the equipment used. You have your pipette filler here. This is the bowl. You put the pipette there. You squeeze the A to release air. The S is pressed to siphon it. And when you want to empty the pipette into, in this case, it'll be the Erlenmeyer flask or conical flask. Erlenmeyer is the proper name for a conical flask. And when you want to enter it in there, you press the E to empty pipette or evacuate the pipette. This is a burette. You see it's graduated. It is a very accurate piece of equipment. It's very sensitive. These are the volumetric flasks. Here you will see lines that say, and it will say on there 250 mils or milliliters at 20 degrees, 1 atmosphere, something like that. So that is telling you not just how accurate it is, but when it is accurate. And then we have the pipette. This is the glass pipette. So, okay, see, you've got the fill line there. That's the graduated line, and that graduated line is 25 milliliters exactly. Well, when I say exactly, plus or minus 0.03. So what it actually is, it's not 25. It is somewhere between 24.970 and 25.030 milliliters. So it's somewhere in between there. That's pretty accurate. Just got the margin of error and the temperature. Again, this is where it's at. This A right there stands for analytical grade. This means that this one here, if it's working properly, if it's going to still be accurate, should hold a liquid in there for about 5 seconds. And after that, it will start to drip. Alright, so titration method. How does it work? What do we do? First, we wash our conical flask with distilled water. That's this guy here. Wash that with distilled water. We're assuming, by the way, at this stage, you've already made your primary standard. That's be covered in another video. A known volume of the analyte is placed into the conical flask. This is done with a pipette or pipette with indicator. The standard being titrated against is placed into the burette. We use that to wash the burette out first. This way, the only thing that's left in the burette is what we're starting with. We're not going to look at the calculations in this video. That'll be a different video. The burette is then filled with the standard solution, and you'll do that with a funnel. And when you put in the funnel, so the funnel will sit, so here's the top of your burette. Funnel goes in like this, and you pour it in there. But before you're finished, you need to lift that funnel out so it's not sitting against there and going to trap air. The standard volume on the burette is recorded, so where it's starting, and up here we can pretend that this one is starting at 21.35 centimeters cubed, which 1 centimeter equals milliliters. The tap or stopcock is opened and it pours into the conical flask here, and we swirl the conical flask like this while we're doing it, and turn. So we turn with one hand, swirl with the other, and eventually the color will change. We then turn it straight off and we record the volume change. Okay, that's our rough tider. Now, from there, we will do another 3 or more if we want. If we're doing this in a proper analytical lab, we'll do many more than 3. We'll do 3 accurate tiders. All this means is you can pour really fast up until about there. Okay, so when you hit nearly 21, so 21.35 was what we measured. So when you hit about 20 or maybe 21, you turn it off and you go drop by drop by drop, and you swirl as you're going and you watch for the color change. It is the first permanent sign of color change. That's when we're done. Now, what indicators are we going to use? There are 3 types of titrations we're going to look at. Now, you pick an indicator which is going to change when that salt is finally produced, or finished being produced. Okay, some salts are basic, some salts are acidic, some salts are neutral. So if you've got a strong acid and a strong base, the salt is neutral, therefore the equivalence point is neutral. Use bromothermal blue, litmus. You can also use phenolphthalein, and that's the one we'll actually use because it gives that nice pink. And you're looking for a baby pink, not so. Right, phenolphthalein down there as well. You look for a baby pink, not a harsh solid pink or purple. Strong acid and weak base, it's going to be acidic. So you'll use something like methyl orange or methyl red. If you're using a weak acid and a strong base, the salt's going to be basic. So you use phenolphthalein. Yeah, I hope that made sense. If you have any questions at all, ask them in the comments and we'll get back to you as quick as we can. Thanks for watching, and we'll see you next time. Bye now.